This video continues on with our division of radicals from our last video. And we're going to start with an example with something like this. If we were to divide this out, we should be able to recognize that this is the same thing as the square root of 3 over 54, which 3 over 54 in lowest terms is 1/18th, which means the square root of 1 on the top is simply 1, and we're left with the root of 18. So here's our answer, which is okay. Two things are wrong with it. Number one, this is not simplified. So let's go ahead and do that next. 1 over the root of 18, that breaks up into 1 over the root of 9 times the root of 2, and the square root of 9 is 3 times root 2. Now this is a little better. Whoops, that's 2. This is a little better, but there's this concept in math that we're not allowed to have a radical in the denominator. So here's a new idea that we have to always consider now. We can't have a radical in the denominator of a fraction. So how do we deal with this? Well, this is where we have a huge concept in the idea of radicals come about. We need to rationalize the denominator. So this is something that you'll see me ask you all the time. Hey, did you rationalize your denominator? Just like, did you simplify your radical? Did you put your fraction in lowest terms? This is a new concept. Did you rationalize the denominator? So let's look at how we can rationalize the denominator from that last example. 1 over 3 root 2. To rationalize this denominator, just look at the denominator itself. I have a root 2 here. If I multiplied the top and bottom, because in a fraction, if I'm multiplying the denominator, I have to also do it to the numerator. If I multiplied both these by that root 2, so by the same thing, what I have is 1 root 2 over 3 times the root of 4. And then if I simplify, 1 root 2 is simply root 2, and 3, the square root of 4 is 2, so I get 3 times 2, which now has root 2 over 6. This answer has a rationalized denominator. This has the same decimal approximation as the original one, but it gets rid of that radical in the denominator. So if I looked at another example and said 7 over the root of 7, look at your denominator and you'll see that the denominator has a root of 7 in it. Can't have a radical down there, so I multiply top and bottom by that radical since it's a monomial, and then I have on the numerator 7 root 7, and the bottom becomes the root of 49, which we get 7 root 7 over 7, because the root of 49 is 7. And if you look at these two 7s, that's 7 over 7. I can divide that out, and I'm simply left with 1 times the root of 7. So this answer is the same as that. But now I do not have a radical in the denominator. And that is key when we're talking about fractions with radicals. So let's look at another one. 5 root 50, or sorry, 5 over the root of 50. There's two things you can do. You can just say, hey, radical in the bottom, I'm going to simply multiply by the root of 50. Nothing wrong with that. You will get larger numbers. I would probably suggest to say, you know what, let's clean that up a bit. Let's say that's the same thing as the root of 25 over the root of 2, because now I can simplify that bottom and I get 5 over 5 root 2, because the root of 25 is simply 5. Now when I look at this, I can still do a little bit more simplifying. 5 over 5. Well, those cancel to 1, so I'm left with 1 over the root of 2. Nice enough answer. However, that rule that I can't have a radical in the denominator comes into play, so I need to rationalize that denominator. So I have 1 over root 2 to rationalize it. Multiply top and bottom by root 2, and you get 1 root 2 all over the root of 4, so the root of 4 is simply 2. This is the rationalized denominator, and this equals the same thing as the one with the radical in the bottom. So those are examples that are basically monomial denominators. So there's only one term or one radical, something happening in the bottom. Now we got to take this a step further, and we're going to talk about a new word, a word that you need to know. And this is probably, when we're rationalizing denominators, this is probably one of the areas where a lot of students make mistakes. And the word we need to know is conjugate. Now, it's just a fancy math word, so it's just another neat word that you have to start to understand. But what a conjugate is, and it'll come clear when we look at some examples, but just by definition, this is basically, this creates a difference of squares and its big use, it's used to rationalize a binomial denominator. So there is a clear distinction between rationalizing a monomial denominator and a binomial denominator. And we're going to look at an example of this one. So here's the example. It's going to say rationalize the denominator. And here's the question. 9 over the square root of 11 minus 8. So this one is a lot different than the ones we've done on the last few examples. The reason being, the denominator itself right down here now has two terms. In essence, it's a binomial. So multiplying just by the root of 11 now, because that's a radical down there, is not going to help us. What we have to do is multiply by something that's called the conjugate. The conjugate is really easy. We basically write the same two terms, so root of 11 and 8, but if this middle term here is a subtraction, this one's a positive. So the middle term between, or sorry, the middle sign between them changes. If one's a positive, the conjugate has to be a negative. If the bottom's a negative, the conjugate has to be a positive. And again, whatever I do to the top and the bottom have to stay the same. So now this is how I have to rationalize this. Now we're going to take this and we're going to look at it through a lot of steps, just so it makes a little bit more sense. So the top of this now is going to become 9 times the root of 11 plus 8. And the bottom, if you examine it, is the root of 11 minus 8 times the root of 11 plus 8. Now this is the difference of squares I was talking about. And the difference of squares now is an easy thing to multiply. So if I was to look at this example, the top, I'll just rewrite it so it's not mixed up with all of that other stuff. So you have here root of 11 minus 8, root of 11 plus 8. I can do the distribution on the top of here, and I get that. So that's 9 root 11 plus 72 all over now. The difference of squares, when we're multiplying that, if you remember from grade 10, you just have to multiply first term by first term. So root of 11 times the root of 11 is the square root of 121, which is simply 11. And then multiply these two. So I get negative 8 times a positive 8 is minus 64. So if you look, I now have no more radical in my denominator. Now I just need to clean house a bit and say, all right, this gets me 9 root 11 plus 72 all over negative 53. My denominator's rationalized. Nothing is wrong with this answer, but you probably see something more like this in an answer key, where that negative is moved from the bottom of the fraction just to out front of the whole fraction. So now we've rationalized this denominator. My denominator is now 53. It's no longer root of 11 minus 8. So let's look at one last example that kind of looks at conjugates. And the example we'll do is 3 root 5 plus 7 plus the root of 7. 3 over root 5 plus root of 7. So we have a binomial denominator again. We have to now multiply top and bottom by the conjugate. So same terms, but opposite sign. This one's a positive, so this one has to be a negative. And likewise over here, the top has to be the same. So if I go to multiply this out, I get 3 times the root of 5 minus the root of 7 all over, now these are a difference of squares, so root 5 times root 5, that's the root of 25, which is 5, and plus root 7 multiplied by a minus root 7 is a negative root 49, which turns out to be minus 7. So this middle term, since it's a difference of squares, will always be a minus on that bottom if I'm multiplying by the conjugate. So now I can go through and simplify that bottom. I got a negative 2. The top, if I didn't want to multiply it out, is this. And now, since there's a negative in the denominator, I can move it out front, or I can move it up top. So here now, if you look, I have a rationalized denominator. I no longer have root 5 plus 7, root 5 plus the root of 7. I simply have root 2. And by convention, we always want to get rid of any radicals that are in the bottom of our fractions.